Our 8 people sitting in these 16 chairs can either be sitting as adjacent pairs or as singles. We'll do casework on the number of adjacent pairs. Our first case will have no people sitting in pairs. So here are 8 people, and we're going to put an empty chair between them. We've placed 7 empty chairs, so we have 1 chair left. We can put this empty chair here at the start or at the end or in between any 2 people. That's 9 spots, giving us 9 ways to arrange case 1. In case 2, we'll have 1 pair of people sitting next to each other. That's 2 people. The remaining 6 will be apart from each other. So in some order, we'll have a pair of people sitting next to each other, and here are the rest of the 6 people. This adjacent pair can be here on the end, or they can be second, third, fourth, fifth, or here on the right end. Let's put empty chairs between each of these groups of people. Here we've placed 6 chairs, and we have 2 empty chairs remaining. We'll stick them on the end here. What I want to do now is create these groups. This last group just consists of our last person. And again, we have 7 ways that we can pick which of these 7 groups will contain the pair. Once we've fixed this order, let's replace each of these groups with stars and bars. This is a star and this is a star. And then we'll replace these empty chairs with bars. This will allow us to count the number of ways that we can insert these 2 empty chairs in and among these groups. We have 7 stars and 2 bars, and we're choosing 2 of them to be our bars. Altogether, ordering our pairs and then inserting the 2 remaining chairs, that's 252 ways for case 2. In case 3, the number of adjacent pairs is 2. That's 4 people, which means the 4 remaining people will be sitting apart from anyone else. Here are 2 pairs of adjacent pairs and our 4 people who are apart. We'll insert an empty chair. We've used 5 chairs already, so we still have 3. We'll group these and note that out of these 6 groups, 2 of them are pairs. So there's 6 choose 2 ways to order these. Then we can replace each of these groups with 6 stars, and these 3 will replace with 3 bars. To count the number of ways of inserting these empty chairs in and among these groups, that's equivalent to ordering these stars and bars. We have 9 objects here, and we're choosing 3 of them to be bars. We'll go ahead and multiply this by 6 choose 2, the number of ways of ordering the pairs among these 6 groups, and that's 1260 ways. Next, we'll have 3 pairs that are adjacent, leaving 2 that are sitting apart from the others. Here's a pair, and here's a pair, and here's a pair. And here are 2 singles. We'll put an empty chair in between. That uses up 4 empty chairs, so we have 4 left. This gives us 5 groups, and we're choosing 3 of them in this order to be pairs. Once we've decided on an order, we replace them with 5 stars and 4 bars. So we'll take 5 choose 2, and this we replace with 9 choose 4. This is also 1260 ways. Our final case has everyone paired up. So that's 4 pairs. We'll put an empty chair in between, leaving us with 5 more empty chairs. There's only one way to arrange our 4 pairs. We have 4 stars and 5 bars, and that's 126 ways for case 5. So now we're going to sum these and find the mod 1000 residual. We've got 9 here from case 1, 252, 1260 for both cases 3 and 4. I'll just go ahead and take the mod 1000 residual and write 260 for both of them. And then case 5 was 126. This adds up to 907 in mod 1000. If you'd like me to solve any other math contest problems, please leave them in the comments.